This lesson is over evaluations of functions with variables. Example 1. Find the following given f of x equals 2x squared minus x plus 3. Part A says find f of negative 1. Now we're given the original function, and whenever it asks you to find f of negative 1, what that simply means is every time you see x, you will take the x out and replace it with parentheses. And inside the parentheses, you place the specified value. In this case, they want us to investigate when x is equal to negative 1. Once you've substituted in the value, now you need to evaluate using GEMS. So on the right-hand side, we look for any grouping symbols. And we cannot do anything inside grouping symbols, so we move to exponents. We do have negative 1 squared, which means negative 1 times negative 1, which gives us a positive 1, and we bring everything else down. From here, we have no more exponents, so we move on to multiplication and division in order from left to right. We do have multiplication in the form of 2 times 1, which we know to be 2, and we keep everything else. Now, multiplication can appear as double negatives. If you've noticed, you see minus negative 1, or you can read that as the opposite of negative 1, which we know to be a positive 1. From here, there's no more multiplication division, so we move on to addition subtraction from left to right. And we see 2 plus 1 is 3. And then the last step, 3 plus 3 is 6. Which means f of negative 1 equals 6. That would be your final answer. Now part B wants us to use the same function, but this time it wants us to find f of 5a. Well, the good news is the steps are the same. So we start with the original function, and every time we see x, we put parentheses in its place. And now we plug in the specified value, which is a 5a. From here, we follow GEMS. There's no grouping symbols, but there are exponents. 5a squared really means 5a times 5a. Well, we know 5 times 5 is 25, and a times a is a squared. So when we put that together, it gives us 25a squared. And everything else is still the same. There's no more exponents that we can do, so we move on to multiplication division in order from left to right. We do have multiplication from left to right in the form of 2 times 25a squared. And so we know 2 times 25 is 50. And we keep the a squared. Now from here, there's no more, there is multiplication in the form of, because we still have the parentheses around the 5a, you could interpret that as a negative times a positive, or the opposite of 5a, which does give us negative 5a, and everything else comes down exactly as you see it. From here, no more multiplication division, we look for subtraction and addition. Now, the question is do we have any like terms? Is a squared the same thing as a? No, they're different terms, which means there are no more like terms, so that is your final answer. Part C wants us to find f of a minus 4. And again, we have the original function of f of x equals 2x squared minus x plus 3. Just like the previous problems, the steps are the same. Every time you see an x, you take the x out and put parentheses in its place. Once you have the parentheses ready, you plug in the specified variable or the specified value. In this case, the value is a minus 4. Again, we follow GEMS, and we have grouping symbols, but notice we cannot do anything inside the grouping symbol. So we move on to exponents. We do have an exponent in the form of a minus 4 squared. So we're going to do some side work on the side of our paper. A minus 4 squared really means a minus 4 times a minus 4. Well, it may be a while since you've done this, so let's kind of refresh our memory. We are going to distribute. So the first value we'll distribute, a times a is a squared. Now we distribute the a again, but this time to minus 4. So a times negative 4 is negative 4a. We're done distributing that a. Now we must distribute the next value, which is a negative 4. Negative 4 times a is negative 4a. Negative 4 times negative 4 is a positive 16. So now we have 4 terms, and we want to see if we can combine any like terms. Well, notice your middle terms, negative 4a and another negative 4a combine to give you a negative 8a. So in place of a minus 4 squared, we now have the value of a squared minus 8a plus 16. And everything else stays the same. Now we've done the exponents. Now we're ready for multiplication division. In order from left to right. Well, starting at the left, we see 2 touching the parenthesis, which means it is multiplying. So we will need to distribute that 2 to each of the values inside that set, which gives us 2a squared minus 16a plus 32. And everything else stays exactly the same. Now another multiplication is of the form, because we have the grouping symbol around a minus 4, we look immediately in front of it. We can read that as a minus, you can read that as a negative 1, or you can read that as the opposite of a minus 4. Well, the opposite of a positive a is a negative a, and the opposite of a negative 4 is a positive 4. So there's 2 sign changes that do take place. Everything else stays the same. Now we have no more multiplication division, so we're ready for addition subtraction. So we look for like terms. Do I have any a squareds that can be combined? No. So we keep the 2a squared. Do we have any values that just have an a attached to them? Yes. We have a negative 16a and another a negative 1a, which combines to give you a negative 17a. Last, we have constants, or our plain numbers. We have a 32 plus a 4 plus a 3, which together gives us positive 39. From here, notice we have no more like terms, so this is your final answer. Example 2. Find the following. Given f of x equals 3x squared minus 2x minus 5. This is your triad problem. For part A, find f of negative 4. For B, find f of 3m. For part C, find f of k plus 2. Let's see how you did. For A, hopefully you found f of negative 4 to equal 51. For B, hopefully you found f of 3m to equal 27m squared minus 6m minus 5. For C, well, it's found on the next page. It took a little more room. For part C, we were asked to find f of k plus 2. So again, every time you saw x, you should have replaced it with k plus 2 and then followed gems. Hopefully you found f of k plus 2 to equal 3k squared plus 10k plus 3. Example 3, given f of x equals 3x minus 7, find f of x plus h. Well, the good news is it's the same steps we've been doing. They gave us a function, and then they're saying, I want you to plug in the value x plus h. The only difference is it's not a number, so you may feel a little uncomfortable. So just like before, every time you see x, put parentheses in its place, then plug in the value x plus h. From here, we follow gems. Notice we cannot do anything inside the grouping symbols. We have no exponents, but we do have multiplication. 3 is touching the parenthesis, so we must distribute, which gives us 3x plus 3h, and everything else remains the same. So now we move on to subtraction and addition, but notice there's no like terms, which means that is your final answer. F of x plus h equals 3x plus 3h minus 7. Example 4, given f of x equals x squared plus 5x minus 6, find f of x plus h. Well, again, we have the given function, and they're asking us that in place of x, we replace it with x plus h. Just like before, we follow gems. Can we do anything inside the grouping symbols? No. Do we have exponents? Yes. So on the side of our paper, we have x plus h squared. Keep in mind, when anything is squared, it means that value times itself. So for us, that means x plus h times x plus h. Now we need to multiply. X times x is x squared. X times h is xh. Now we distribute the next value. H times x is the same thing as xh. H times h is h squared. So now we have 4 terms, and we want to see if we have any like terms. Notice the terms in the middle. We have an xh and another xh. So how many do we have? Well, we have 2 of them. So we can simplify those 4 terms into 3 terms, which now has a value of x squared plus 2xh plus h squared. That takes the place of the exponent. Everything else in your expression stays the same. From here, we have no more exponents that we can do, so we move on to multiplication division. Notice there's 5 touching the parenthesis, which means we do need to distribute. And when we do, that gives us 5x plus 5h. Everything else stays the same. We have no more multiplication division, so now we move to addition subtraction, which means, do we have any like terms? Well, do we have any other x squareds? No. Do you have any other terms that have an x and an h? No. Do you have any terms that have an h squared? No. How about just a plain x? No. How about an h? No. And what about a constant? No. It turns out there are no like terms. So that actually is your final answer. F of x plus h equals x squared plus 2xh plus h squared plus 5x plus 5h minus 2. Example 5, given f of x equals x squared minus x minus 2, find f of x plus h. This is your try it problem. Let's see how you did. Hopefully you found f of x plus h to equal x squared plus 2xh plus h squared minus x minus h minus 2.